Thank you very much. Thank you, first of all, to the organizer of this software GIS, fifth GIS Software Technology Conference in 2022. So I'm Asib Ahmed, associate working as an associate professor, the Department of Geography and Environment, University of Dhaka. So my topic today is to discuss is about water resource management using GIS technology. So everybody, I think, is aware about the water resource and water resource crisis. So today, I will have a discussion on the availability of water and the distribution of water surface on Earth. That is very important because if we have a clear idea about the distribution of water surfaces on Earth, then we can have some ideas about how we can manage it. Then the water resources. So all of the water are surface water are not usable. So we have to think about the portion of water that we can call it resource. So then we can come to water resource management aspects, and then the challenges that we are facing in water resource management. And then finally, the main thing is how GIS can have this kind have the facilities to handle this kind of water resource management issues. So first of all, we all know that in our Earth surface, we have about 71% of water and 29% of land. And so in this 29% of land, we normally have the continental surfaces. We have some mountainous areas and other areas. But in 70% of water bodies, we have a huge diversity of features in that water body. Some waters are in freezing conditions, some water are in liquid conditions, some water are usable, some water are not usable, like this. So first of all, I'll have some this kind of things, that what we have, what kind of features of waters in our surface we have to discuss this kind of thing first. So this water body, 70%, 71% of water body contains approximately 1.4 billion square kilometer of water, if we just measure this kind of thing. And over 97% of water is in the oceans. So we have to think about the oceans first, and then we have to think about the interior coast, and then the inland water bodies as well. So around for this 71% of water, the total mass is about 1.4 into 10 to the power 18 ton. That is a huge mass. And if you think about the total volume of water on Earth, then it would be around 1,386 million square kilometer volume of water on Earth. And if you think about the area that covered by the ocean, that is around 361 square kilometer area. And the average salinity of water of Earth's oceans, if we think about the salinity, because it is very important for water resource management, and then that is 35 gram per kg of seawater, and we can say this as 3.5% of the average salinity in ocean water. So if we summarize this Earth's water resources, then ocean water contains about 97.2%, as I mentioned earlier. But if you think about the glaciers and other ice portions, then it is also very important because it covers around 2.15% of water body that is in glaciers and other ice caps. And then if we come to the groundwater, that is also very important because we have some distributional processes for groundwater. So like we have underground seepage, we have underground water flow, and then that can come to the main water bodies that will also add to the hydrological cycle. That's why groundwater is also important, and that covers around 61% of area. And if we think about the freshwater lakes, that contains only about 0.009%. If you think about the inland seas, that is very less, and that is 0.008%. So if you think about the soil moisture, that is also a portion of water body you can consider, that is 0.005%. If you think about the atmosphere, that is 0.001%. But if you think about the rivers, that means the internal rivers, especially in humid geomorphic environments, that is very less portion of water contains the river in the river. So like it's 0.0001%. So these are the Earth's water resources that we have in percentage. And if we make a summary of this kind of water body, it is Earth. Then if we think about the hydrosphere, then it covers only around 70% of surfaces. But the fresh water that we have seen in earlier slides, that the freshwater lakes, rivers, and atmosphere and soils, that contains only about 2.5% of the total hydrosphere. So for Earth's water resources, water accounts for a very mere 0.023% of the Earth's total mass. But of that mass, only a small percentage, we can say about 0.3%, is even usable by humans. That is very important thing. Only about 0.3% is even usable by humans. So other 99.7% is in the oceans, soils, ice caps, and floating in the atmosphere. So still, much of this 0.3% is usable, is unattainable, but usable portion is also sometimes maybe unattainable. So we have to think about this kind of very little amount of usable water for water resource management. So if you think about that, around only 3 or 2.5% of fresh water of the total amount of water, in that fresh water, we have around 68.7% are in glaciers and ice caps, and around 30% is in groundwater, but only about 1.2% is surface and other fresh water. So if we again think about the surface and other fresh water or surface water, in that portion, we have ground ice and permafrost that covers around 69%, and lakes covers around 20.9%. In atmosphere, we can have 3%. In soil moisture, we can have 3.8%. Swamps, marshes can have contain 2.6%. Rivers can have 0.49%, and living things can have 2.6%. So these are the distributions of surface and other freshwater things. So here we can also have some unattainable water bodies that the human cannot attain this kind of surface water, that are fresh water. So for this kind of issues that can we have discussed right now, that implies that we have a very little amount of water body that are very usable for human beings. So that's why we have to think about the water resource and water resource management. And that's why this is a resource, because this resource must have a characteristic that is a scarcity. So we have the scarcity. So we have to think about it as a resource, and we have to think about its management. So that's why this is we are discussing about the water resource management. And now we can think about what is water resource management. Water resource management is simply a process of planning, developing, and managing water resources. So planning means how we can think about how we can use this kind of water bodies for future purposes, and how we can distribute it, how we can fulfill the demands or the needs of the people or the human being. So this kind of planning processes are involved in water resource management. And then developing how we can generate this kind of fresh water or how we can make it usable for the people who are using this kind of water resources. And then managing, that means how we can just reduce or minimize the loss of fresh water in terms of both quality and quantity. So these are water resource management. This is water resource management, that is the process of planning, developing, and managing resources in terms of both quantity and quality across all water users. So it also includes the institutions. It also includes the infrastructure, incentives, and information systems that support and guide water management. That means you have to have an institutional body. You have to have some infrastructures and incentives as well, and especially that is the focus of our today's discussion, the information system. So if you have institutions, if you have infrastructures, if you have incentives, but if you don't have any information systems that can be used for this kind of management, then you will fail to manage this kind of water resources, this very scarce water resource. So that's why in today's discussion we'll have a glimpse on how information system or how GIS can be used for planning, developing, managing water resources. So this is our main topic. So before going to the use of GIS in water resource management, we have to think about the challenges in water resource management. We have we are in the verge of a very crucial moment of managing water resources, because in 2017 we had 40% of the people, world population, live in water scarce areas. That is very big amount of percentage of people who live in water scarce area, and approximately 1/4 of the world's GDP was exposed to these kind of challenges. So this was very crucial thing in around 2017, but by 2025 it will be very worse conditions. So like about 1.8 billion people will be living in regions or countries with absolute water scarcity. That means that will be very near to desert or desertic conditions. So 1.8 billion people will suffer from this kind of water scarcity. And with current practices, if we think about the current uses of water body, then the world will face around, say, like 40% of shortfall between forecast demand and available supply of water by 2030. So from now on to up to, say, like next by 8 years, around 40% shortfall will be forecasted for this kind of resource challenges. So further things, say, like chronic water scarcity, hydrological uncertainty, extreme weather events like floods, droughts are also perceived along with this kind of uh, issues that we have just discussed right now. So these are also the threats for water resource management. So in humid geomorphic environment, we are facing flooding problems. We are also facing droughts, and so these are due to the climate change issues are just coming. So that's why these kind of issues will these extreme weather events will be increasing day by day in future, say like floods and droughts, etc. So these are or will also affect on water resource management issues. These will be the highly challenging issues in future. So what integrated water resource management do in water resource management? So we have to think about the integrated approach. This is because the issues of water resource management is not a separate issue. So many other things are also related. Many site-specific factors and many other factors or issues are relevant to this kind of water resource management. So in these issues, so that's why we need an integrated water resource management scheme, and that will help us to identify water resource monitoring issues, to help us in decision making under uncertainty or uncertain issues, say like uncertain climatic conditions, and then we can think about integrated water resource. For integrated water resource management, we can think about system analysis, and we can also have can think about the hydrometeorological forecast and warning as well. So for all these purposes, we have to think about integrated water resource management. So for integrated water resource management, what GIS can assist us, or how we can deal with this kind of challenges that we have discussed today, how we can handle this kind of issues in GIS. So for this, we can think about a hydro geodatabase that will be very helpful for us to tackle this kind of issues, and to think about water resource management. So what hydro geodatabase can deal with this water resource management? So many aspects we have that we can resolve or solve, or we can analyze in GIS platform. But here is the summary of some aspects or some issues that we can handle in GIS platform. So as for example, we can think about water quality analysis. For water quality analysis, what we can do, we can do a lot of things in GIS platform. For example, we can model water quality. That means so we can assess the and model water quality of the rivers or the lakes, or some uh, uh, areas where we can find the available water. We can also use GPS or photographic type points that can also uh, uh, will be helpful for assessing water resources, water quality analysis. We can use a passive and active water quality monitoring systems as well for ensuring water quality analysis. So next to water quality analysis is flood management. So in flood management, we also can have some features that GIS can handle. So in flood management, first thing is that uh, uh, we can assess the flood susceptibility. That means how in what areas are very prone to a flood. This is also possible in GIS platform. For flood management, we can have some also specific issues, say like floodplain delineation. If we think about the floodplain areas, and if we are able to delineate this kind of areas, then I think we can have an idea about the flood generation, and then this is the propensity of the flood, and the lead time period, and the duration of the flood. So this is very important to identify the floodplain delineating floodplain area, and this is possible in GIS platform. And then we have to think about the channel characteristics. So which channels are just carrying what amount of water we have to identify these kind of things. So in channel for identifying channel characteristics, hydro database can assist you. That means GIS can assist you. We can also identify, we can also model the inundation um, platform here. We can also analyze the infrastructures. We can also identify the risk model in this GIS platform. So next to flood management, we can think about the watershed management. So in this watershed management, what GIS can assist? GIS can assist in modeling terrain, in modeling flow analysis, in modeling debris flow probability, and we can also identify the stream order analysis in watershed for analyzing watershed management. And then we can think about groundwater modeling. So in groundwater modeling, we can, if we have the borehole data, or we can have the subsurface water conditions data, we can make some 3D analysis in this GIS platform, and then we can identify the flow rate, advections, and concentrations of the water body underneath the surface. And then we can also perform oil and spring models in GIS platform. So these are some example areas where GIS can perform well for managing water resources on the Earth's surface. So these are so like real uh, analytical some screenshots of this real analysis. So like we can for managing water resources, or for distribution of the water resource, water bodies or water resources to the people who are living in different areas. So in that sector, GIS can also assist you. So like we can think about for pipeline, we can think about the collision analysis. So we can have this kind of database and we can think about this potential collisions of this pipeline. We can identify the profile checking. If we have this kind of distribution networks, then we can identify the profile checking, and then we can also simulate the burst conditions where this kind of potential burst areas can be identified. This also can be possible in GIS platform to identify this kind of burst simulations. We can identify the pipeline distribution networks. We can identify the shortest route search in GIS platform. And also we can have like a pipeline excavation. We can identify the potential pipeline excavation areas in GIS platform. So all this will assist you in managing and distributing water resources to the people living in different settlement areas. And what will be the application mechanisms of this kind of water resource management in GIS? So we have a very comfortable environment in GIS. So like we can have some vector data models, shapes, and we can have some raster data model, and we can have some georeference data, tabular data. In that we all together we can integrate it in GIS, and then we can perform some overlay analysis. We can perform some quantitative and qualitative hierarchization of informations, and then we can also have some specialized visualizations in GIS platform. And finally, all this overlay, quantitative and qualitative analysis and specializations can have an analysis of information or interpretations of special correlations of different phenomena in this analysis procedures. So, and then from this analysis, we can have some elaboration of diagnosis, or we can and can be helpful for planning strategies and decisions making. So this is an overview of how we can integrate all this kind of resources, all this kind of information. Say like some can be raster databases, some can be vector databases, and some can be georeference tabular data. So all are possible to related to this kind of water resource management. All are possible to integrate in GIS, and then we can perform this kind of things. And then finally, we can have analysis, and then can have the elaboration of this kind of analysis, and can have some planning strategies and for decision making. So this is the very generic overview of the application mechanisms of GIS in water resource management. And in GIS, we have some, so like we use hydro modeling in GIS, and in hydro modeling can assist you in different ways. These are some examples. For this can assist you in capital improvement plans. This can assist you in wastewater utility. This can assist you in flow analysis. This can assist you in water quality, or the simulation modeling can assist you for future growth of the distribution system, and can be helpful for mapping capital assets in GIS, in hydro GIS modeling. So these are the areas, these are the potential aspects of this hydro modeling things. So these are very overview of using GIS in water resource management. So these are the things that we have to discuss today. And I think if you have any questions, then we can discuss further. Or if you just make a check inbox, then I can reply you more. Thank you very much.